So this video is about distance, and it's more specifically about midpoint, because we did have one about distance already. But one thing that I want you to do for this video that I didn't require you to do for the last video is to take notes on it. So you might, and what I'm going to do is when you submit it on Google Classroom, I'm going to have you submit that you not only watched it, but submit a picture of the notes that you took with it. So you may want to pause this and go get a notebook and a pen and come back. And so I'm going to start by making a graph, and I'm going to plot the 2 points. So here's my y-axis, here's my x-axis to go to 2, 5, 1, 2, 1, 2, 3, 4, 5. That's 2, 5, and 1, 2, 3, 4, 5, 6, 7, 8. And this is going to be 8, -3. And what I want to know is I want to know the distance between those 2 points. And what I told you to do is to construct or create or draw a triangle, a right triangle, because then we can use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. And in order to do that, all I have to do is just count 1, 2, 3, 4, 5, 6. This is the horizontal distance of the leg, and then 1, 2, 3, 4, 5, 6, 7, 8. 8 is the vertical distance, and so we would get 6 squared plus 8 squared is equal to c squared. C, remember, is the hypotenuse, which is the long end, which is the side that's opposite the right angle in a triangle. And I get 64 plus, I get 36 plus 64 is equal to c squared. That is 100. And so c is going to equal the square root of 100, which is 10. And so now I know that this is 10 right here. What I didn't spend a lot of time on that last video is using the distance formula. I think I may have given it to you, and I want you guys to be aware of the distance formula. But there's kind of a lot going on in the distance formula until you break it down. So in this video, I'm going to break down the distance formula a little bit more. So, and actually the distance and the midpoint and the slope formulas are all related in the notation that they have. Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And if you think about what those things are, when I'm looking for the distance, I'm always going to be given 2 points. You can think of point 1 and point 2, and each point has 2 different parts. So this 2 right here is the x coordinate of point 1. This 5 right here is the y coordinate of point 1. So I'm thinking of that as x1 comma y1. 8 is the x coordinate of the second point. -3 is the y coordinate of the second point. So that's what those points mean. And you could draw sort of like a set of maps of where the different arrows point to and stuff like that, if that helps you. But the other thing to keep in mind is that what I'm really looking for is the distance between these two on the x-axis. What I did was I counted before, but I could think of that as just subtracting. To get that distance right here, I'm taking the right edge, which is 8, and I'm subtracting the left edge, which is 2. And to get the vertical distance, I'm taking the top, which is 5, and I'm subtracting the bottom, which is -3. This is a little better. And then I'm going to square both of those things, and I'm going to square root them, and that's where you get that formula. So for midpoint is pretty similar. What I'm looking to do is I'm looking to break this line. I'm looking for the point that breaks this line in half so that I have 2 equal length halves. And we know that the length of the whole thing is 10. then the length of each of the halves should be 5. So how am I going to do that? Because it would be nice if we could just eyeball it like I did, but we need to be exact, and so we need a process that makes us sure that we're exact. So the midpoint is going to be a little different than the distance because the distance is one number. The midpoint is going to have two parts to it. It's going to have an x-coordinate, it's going to have a y-coordinate. So to get the x-coordinate, I want to think I'm going from 2 to 8 on the x-axis. That's a total of 6 spaces. The middle of them is going to be when I go half of 6, which is 3. So if I put a dot right there, that's 1, 2, 3 spaces from 2, and it's also 1, 2, 3 spaces from 8. And if I do the same thing on the y-axis, I'm going from 5, 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces there, so I'm going to go 1, 2, 3, 4. And now my midpoint is going to be the point where I go to these two coordinates. And what is that coordinate? That's going to be halfway between 2 and 8 on the x-axis, which is 5. And it's going to be halfway between 5 and negative 3 on the y-axis, which is 1. And the formula for midpoint is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So in this particular case, this would be 2 plus 8 divided by 2, comma, 5 plus negative 3 divided by 2, which is 10 divided by 2, comma, 2 divided by 2, which is 5, comma 1. And I don't know if this is one other thing I could show you is that if you look at what happened with this midpoint, I created two triangles here that were each right triangles that were kind of similar in that they had a leg of 3 and a leg of 4. And if you need to prove that it is the actual midpoint, you may want to commit to memory that a right triangle with legs of 3 and 4 is always going to have a hypotenuse of 5, because you'll see it all the time. You may not want to spend the time calculating it every time, but now we've shown that these two lengths are identical. So I think we should practice some more. Let's say find the distance between negative 1, 8, and 3, comma 4. So I'm going to start by graphing it. This time I'm going to do this graphically, and then next time I'll do it formulaically. So let's say this is negative 1, 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2, 3, 1, 2, 3, 4. Okay, so if I'm finding the distance there, I'm going to graph it. And I got 1, 2, 3, 4. This has a length of 4. 1, 2, 3, 4. This has a length of 4. So I'm saying x squared is equal to 4 squared plus 4 squared, which is 16 plus 16, or 32, which means x is going to equal the square root of 32. And for the concept check, what I want you to do is put that into a calculator and round it to 1 decimal place. So you may have a calculator that looks different than this. This is the one I'm going to use. I get 5.65, and I'm going to round that to 5.7. Okay, so for the midpoint, I'm going to look, I know that these are a distance of 4, which means I'm going to go 1, 2 from there. And I know this was a distance of 4, so I'm going to go 1, 2 from there. And I'm going to go to the point that's right there. And the midpoint is going to be that coordinate, which is 1 on the x-axis, and 1, 2, 3, 4, 5, 6 on the y-axis. And then for problem 3, I'm going to do it using the formula. So this is x1, this is y1, this is x2, this is y2. And my distance formula is x2 minus x1 squared plus y2 minus y1 squared, and it's the square root of that. And my midpoint is going to be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And so now my distance is going to equal the square root of x2, which is 4, minus x1, which is negative 2 squared, plus y2, which is 5, minus y1, which is 0 squared, which is going to be the square root of 4 minus negative 2, which is 6 squared, plus 5 squared, which is the square root of 36 plus 25, which is the square root of 61. .8. And the midpoint is going to equal x1 plus x2, so negative 2 plus 4 divided by 2, comma, 0 plus 5 divided by 2, which is going to equal negative 2 plus 4 is 2 divided by 2, comma, 5 divided by 2, which is 1, comma, 2.5. And one thing I could do to check my work, there's a lot of things I could do to check my work, but we could just kind of use Desmos to take a look and see if it looks right. So I'm going to put in the points negative 2 comma 0 and 4 comma 5, and then I'm also going to put in the midpoint that I found, which is 1 comma 2.5, and I'm just looking to see if it looks like I'm right. And to me it does. It looks like if I connect these points right here, this looks like it's the same length as that. If I draw the slope triangles, they look like they're the same slope. So I'm going to conclude that I did